I will stop the recording after the formal portion of the meeting. So thank you. Well, my name is André Choquet. I'm president of Mattel & Partners. It's my pleasure to welcome you to this series of webinars on the theme, Is a Climate Strategy a Necessity for Asset Owners? And by asset owners, I mean pension plans, foundations, endowments, and family offices. I have 30 years of experience helping pension plans manage risks and opportunities to deliver better risk-adjusted returns for their beneficiaries. And I've spent the last 8 years integrating environmental, social, and governance factors in the investment policies and strategies of plans. I'm a qualified actuary and a chartered investment manager, and I'm currently writing a certificate on climate risk evaluation and investing from the Chartered Financial Analyst Institute. And I'll share with you some of the very latest insights on this topic. So over the next 4 weeks, what I'd like you to consider with me are the following questions. Why should you be concerned about climate change when making decisions about the investments of your assets? What are investors, regulators, and heads of states around the world doing about climate change that ultimately impacts you as a fiduciary of a pension plan or a foundation? And what actions should you take in response to this? So on this last point, there are benefits for acting early, and there are potential costs for acting late. One example is being invested in stranded assets. So the pressure for acting now comes from 3 angles. One is environmentally. We'll review today the climate science. And another factor is financially. So climate risks are financial risks, but there are also opportunities available in the transition to net zero and in adapting to physical risks. So your investments also have a real impact on the planet itself. So we'll cover this in week 2. And finally, legally, there are local and global regulations, guidelines, standards, and agreements that ultimately impact you as an investor. And we'll talk about this in week 3. So my goal at the end of 4 weeks is for you to have more conviction about whether or not you need to make a move and start a climate strategy to better manage your assets in the best interest of your beneficiaries. I'll just go over a few administration rules. So please use the chat during the presentation if you want to ask any questions or make comments. This series of webinars is for information purposes only. Please don't make decisions based solely on these seminars, except maybe the decisions to learn more. I'll tell you at the end about the services I'm able to offer to you. I want to respect your time, so the formal recorded portion of the webinar will last no more than 30 minutes. I'll continue for another 15 minutes for those of you who wish to stay on and discuss the topic. I encourage exchange of information in between meetings. So that's why I've set up a WhatsApp group. Many of you have lots of experience and you can offer some insights or new information to others in the group. It's always good to interact between asset owners. So like I said, I started a WhatsApp group. It'll last for 4 weeks. After that, it'll be erased. So just mention to me in the chat or in a private email if you don't want to be part of this WhatsApp group. Let me just share my screen for a second. So for those of you who live in Ontario, the summer of 2025 will go down as one of the costliest summers for flooding in Ontario's history. In fact, this past summer sits just behind 2013 as the most expensive for the province in terms of insured damage for floods. And this, of course, accompanies other extreme weather events just south of the border with Hurricane Helene and Milton that hit the U.S. earlier this year, which have cost several $1 billion of losses. So the first step in understanding the impact of climate change on your investments is to appreciate, and I would even go as far to say as to have reverence for the science behind the climate. So in the next 20 minutes, I'll cover how the energy of the sun is regulated by our planet to provide a livable environment. What are the forces that disturb this balance through time, including human-caused forces? And I'll briefly cover the feedback mechanisms between the various components of the Earth's climate system, which makes predicting global warming a very difficult science, almost as difficult as actuarial science. I'll finish like I'll do every week with a story to bring our emotional mind and our rational mind together. So if you're ready, let's dive into climate science. Just want to check nobody else is joining. No, okay. So imagine for a moment you are a stream of energy emitted by the sun. You're a form of shortwave radiation composed mostly of visible light, as well as infrared and ultraviolet light. And what happens as you travel towards the Earth? Well, not all of you will be heating our planet. Overall, about 30% of you is reflected back into space. 6% is reflected by the atmosphere, 20% by the clouds, and 4% is reflected off the surface of the Earth. White surfaces like ice reflect more than dark surfaces like asphalt. So the remaining 70% is absorbed by our atmosphere, oceans, and the land. So that's the yellow arrow on the screen. As the Earth absorbs solar radiation, it warms up and emits energy in the form of long-wave infrared radiation back into space. So that's the red arrow. So this energy balance between incoming solar radiation, reflected solar radiation, and outgoing thermal energy has allowed the human race to exist for at least the last 10,000 years since the last ice age. That was what scientists call the Holocene period. So if more energy is absorbed than emitted, the Earth starts boiling up. And conversely, if more energy is emitted than absorbed, then the Earth starts freezing over. So let's see how each of the Earth's climate system components reacts to incoming solar radiation and outgoing infrared radiation. Let's start with the atmosphere. The atmosphere plays two critical roles in regulating the Earth's temperature. First, it absorbs and reflects radiation from the sun, as well as infrared heat from the Earth's surface. Second, it moves the air around the planet, redistributing heat. So the atmosphere is mainly composed of nitrogen and oxygen, which absorbs very little radiation. But greenhouse gases like carbon dioxide, methane, nitrous oxide, and water vapor in the atmosphere trap the heat, which causes global warming. Next, the oceans. So water has a much higher heat capacity than air. So the oceans act as a massive heat sink, absorbing energy from the sun and the atmosphere, storing it as heat. And this heat is redistributed by ocean currents, like the Gulf Stream, which brings warm water from the Caribbean to Western Europe. Deep ocean currents carry heat away from the surface, storing it for decades or centuries, which helps stabilize temperature changes. So climate change increases water temperature, leading to more intense hurricanes, as we'll see later. Now let's consider the land surface. So land plays a relatively minor role in global heat storage. It warms during the day and cools at night. But the interesting thing is that darker surfaces, such as forests and asphalt, absorb more sunlight and cause warming, while lighter surfaces like deserts and snow reflect sunlight and contribute to less warming. And finally, sea ice. Sea ice is primarily found in polar regions and is crucial for regulating Earth's temperature. It acts as a white mirror, reflecting the sunlight back into space. The response time of climate system components vary as shown in this table. So the atmosphere is the most volatile and it quickly redistributes heat in a matter of hours or weeks. Oceans react more slowly, taking years for surface currents to warm up and 100 to 1,500 years for deep ocean currents to warm up. Ice sheets may take thousands of years to collapse due to historic warming. So what science tells us that even if fossil fuel emissions were to stop today, some scientists expect that the Greenland ice sheet may already be facing an inevitable collapse due to historic warming. Although if it were to happen, it could take thousands of years to totally disappear. So what we need to retain here is that each of the Earth's climate system react differently and at different speed. So when scientists develop climate scenarios of how global warming may unfold in the future, it's crucial for them to consider these factors, even if they are not sure how they will interact. And climate scenarios, by the way, are used by economists, central banks, actuaries, and other risk professionals to model the impact on our economies, our financial system, and on your portfolios down the road. So we'll talk about this a little bit more next week. Now, what are the causes of climate change? So there are natural causes of climate change on the left. So variation in solar energy output can lead to changes in warming or cooling. We know of an 11-year cycle that causes small oscillations in solar output. The Earth's orbit and tilt also plays a role. 100,000-year cycle drives long-term climate changes affecting the growth and retreat of ice sheets over millions of years. Volcanic eruptions, more short-term, more in the recent term, volcanic eruptions release aerosols. Aerosols are tiny little particles and droplets in the atmosphere, and these aerosols scatter and reflect sunlight, reducing incoming solar radiation and cooling the planet. For example, Mount Pinatubo's 1991 eruption cooled the planet by about 1 degree Celsius for at least 12 months. The movement of the Earth's continents and other long-term effect influences global warming too. The reflectivity of the Earth's surface varies with the presence of land or oceans. So continents have a higher albedo, meaning reflectivity, than oceans, and they can reflect more solar energy. Now, about the human causes, well, burning fossil fuels, deforestation, industrial processes have led to the release of greenhouse gases like carbon dioxide, methane, and nitrous oxide into the atmosphere. As we saw earlier, these gases absorb and re-radiate outgoing infrared radiation, contributing to global warming. Human activities, including industrial emissions and biomass burning, produce aerosols that can either scatter or absorb sunlight. And finally, the alteration of the Earth's surface due to urbanization, agriculture, and deforestation can change the reflectivity of the Earth's surface, leading to localized warming or cooling. So the next slide shows that the human causes of climate change by far exceed the influence of natural causes on climate, at least since the Industrial Revolution. The anthropogenic effect. I won't say the word anthropogenic again because it's hard to pronounce, but it means the effect of human activity. So this figure from the UN Intergovernmental Panel on Climate Change summarizes the relative contribution of different human activities in radiative forcing from 1750 to 2019. Radiative forcing is another scientific term meaning the forces that affect the balance between incoming and outgoing radiation. So the strong positive radiative forcings represented by the red bars and associated with greenhouse gases emissions contribute to more global warming. And the blue bar is the negative forcing associated with human-caused aerosols, for example. At the bottom is the negligible contribution of small changes in solar output. So basically, the main point of this chart is that the natural radiative forcings have barely changed over the industrial age. Instead, it's the continuous emission of greenhouse gases and polluting aerosols that have thrown the Earth's energy budget out of balance, leading to warming of our atmosphere and oceans. And the result, of course, is rising temperature. Many agencies monitoring the Earth's temperature are providing similar results. We see here 5 observatories, including NASA, that have tracked global temperatures since 1880. Prior to that, observations did not sufficiently cover enough of the planet. But their results all coincide. Now, before getting to our story, one last scientific topic I'd like to dive into is the climate feedback mechanisms. These are processes that can either amplify or dampen the effects of climate change. Let's start with positive feedback mechanisms, which means mechanisms that speed up global warming. So on the right or in the middle, you have ice reflectivity feedback. So when ice and snow melt due to warming temperatures, they expose darker surfaces like water or land. So these darker surfaces absorb more sunlight, leading to further warming and more melting, creating a self-reinforcing feedback loop. Another loop happens with water vapor feedback. So warmer temperatures increase the amount of water vapor in the atmosphere, which is a potent greenhouse gas. And then more water vapor leads to more warming, causing even more water vapor to enter the atmosphere. Now let's look at negative feedback mechanisms. So these are mechanisms that slow down global warming. So one is cloud. Cloud actually plays an important role in global warming. So low-level clouds can reflect sunlight back into space, which has a cooling effect on the planet. If warming causes an increase in these clouds, it could mitigate some of the warming overall. Another important mechanism is chemical weathering. That means weathering is a process that removes carbon dioxide from the atmosphere and stores it in the earth, acting as a natural carbon sink. So it's a natural process that happens over time. So warmer temperatures can actually enhance the weathering attributes of rocks. And then there are complex feedbacks. So these, for example, the permafrost thawing is one. Thawing the permafrost releases stored carbon and methane into the atmosphere, both of which are greenhouse gases. So this can lead to further warming and more permafrost thawing, but it could open also areas for trees to grow, which can act as a carbon sink. And lastly, ocean circulation. So changes in temperatures and salinity can affect ocean currents, which plays a critical role in distributing heat around the planet. So distribution in these currents can have a wide-ranging impacts on global climate patterns. For example, scientists are studying how changes to the Gulf Stream currents due to less salinity could lead to cooler temperature in Western Europe. So these mechanisms highlight the intricate and interconnected nature of our climate system. They underscore the importance of considering feedbacks when predicting future climate change impacts. Although we may understand how these feedback work, scientists have difficulty predicting how fast these will occur. And recently, 2023 has been, identified as the warmest year on record. And scientists are starting to realize that, global warming is occurring faster than what they had expected 10 years ago due to these feedback mechanisms. So that's why scientists are sounding the alarm that we may be playing with fire if we continue at this pace. An overshoot above 1.5 degrees Celsius is dangerous because it could amplify these feedback mechanisms, which could lead to tipping points being reached. And tipping points are basically points of no return with our systems. So I promised you a story. Let me go to the story of the island of Dominica, which is a country in the Caribbean. It was known for its lush rainforests, pristine rivers, and vibrant culture before it woke up to a nightmare on September 18, 2017. As the sun dipped below the horizon, the skies over Dominica darkened ominously. The once serene atmosphere was soon replaced by howling winds and torrential rains. Hurricane Maria, a monstrous Category 5 storm, unleashed its fury upon the island. Trees bent and snapped like twigs, roofs were torn apart from homes, and power lines crumbled under the relentless onslaught. Amidst the chaos, families huddled together in whatever shelters they could find. The sound of the wind was deafening, and the walls trembled with each gust. It felt like an eternity, but by the time the storm passed, the island lay in ruins. Over 90% of the island's structures were destroyed or severely damaged. 80% of the population was directly affected. Entire communities were flattened, and the once bustling capital, Rosso, was reduced to a ghost town. The island's economy, heavily reliant on agriculture and tourism, was shattered. Crops that provided livelihoods for many were wiped out, leaving farmers with nothing but barren fields. The tourism industry, which had been steadily growing, came to a screeching halt as hotels and attractions were left in ruins, like the one in this picture here. For the people of Dominica, the economic consequences were severe. Jobs vanished overnight, and the flow of income that sustained families dried up. While it's a challenge to attribute a single event like this directly to climate change, scientists agree that climate change can increase the likelihood and intensity of such extreme weather events as the warmer water and air lead to stronger hurricanes. Recently, I was at a Canada Caribbean Symposium on Climate Change at McMaster University last month, and the conference co-chair, Lincoln Edwards, said, "No single issue is more important to the Caribbean than climate change, because its impact can be felt for many years." And a similar statement was made at COP29 the other day by the Filipino representative, Petet Nera Lauren, when she said that climate change is a matter of life and death, not an investment decision. So this webinar series is complimentary. It's a sample of what I could do for your organization. My 30-year career as an actuary and investment professional makes me an expert who can help you discern what in the field of ESG and climate change can be classified as valuable information versus noise. I'm an advocate of policies, processes, and strategies to help meet your long-term goals of sustainability for your plan and the financial well-being of your beneficiaries. What I seek for is to partner with a few organizations to help them move forward from being a traditional institutional investor to a proactive, responsible investor. How we'll do this is by first educating and level setting everyone on what we need to know about this complex and uncertain challenge that is climate change. I will then conduct workshops to help build an action plan. The workshops are all about understanding where you are now and where you want to be. This typically includes people at senior management level of the company, as well as those involved in day-to-day decision-making for the investments of the assets. Understanding where you are includes addressing goals for your plans regarding financial materiality or double materiality. We'll talk about this concept in week 4. Assessing the ESG and climate change data you are getting from your OCIO or asset managers. It also means assessing the risks and opportunities you are facing. Knowing what your peers and best-of-class asset owners are doing can also help. After that workshop comes development of an action plan. Building the action plan includes establishing proper metrics, engagement activities, reporting requirements, and timelines. Implementing the action plan involves communicating with third-party providers, negotiating agreements, and monitoring results. And the last step is to plan for formal reviews of the strategy every 3 years, for example. So I hope I can work with some of you on an ongoing basis. And like I said, I set up a WhatsApp group. And next week, we will cover climate risks or financial risks. We'll talk about transition risks as we are marching forward towards a net zero economy, and physical risks, and also adaptation to climate change activities. So the picture is not all grim. There are opportunities available to investors in our march forward. So I'll turn off the recording and I'll stop sharing first. Yeah. And I'll open the floor for questions or reactions.
Probably I can introduce myself. I'm a business coach operating out of the Caribbean. And I'm well aware, as you said, that Mr. Edwards said that the biggest issue